Welcome everybody again to another episode of the ideaXme show. I'm Andrea Macdonald, the founder of ideaXme. ideaXme is a global network, a podcast available in 40 countries worldwide, a creator series and mentor program. Our mission is to share knowledge of the future. Today we're going to talk about space science and engineering. We're going to talk to the head of SpaceTREx, who will take us through the latest developments there. In your words, who are you?
I'm Assistant Professor Jekan Thanga. I'm a head of the Space and Terrestrial Robotics Exploration Laboratory, or SpaceTREx, at the University of Arizona. We work on small spacecraft, space technology, new methods of exploration, all sort of new and upcoming areas that are, of course, very interesting and exciting in the arena of space exploration.
All of this work has culminated in a big idea in which you bring in all the recent technological and engineering breakthroughs and innovation from SpaceTREx. Could you take us through what that project is, and also the amazing technology and engineering?
I can mention a little bit of a background about SpaceTREx. It was founded about 8 years ago, and it was a new era, really, in space. The space era really started in 1959, and it's sort of been the next revolution that we're in the midst of. And that started in the mid 2000s. And when we started SpaceTREx about 8 years ago, it was at a later stage. But what was important is this revolutionizing of and miniaturizing of space technology. We're seeing miniaturization at play on the ground. We're seeing smartphones, which are, compared to the 1960s, like supercomputers in your pockets. And we're seeing all kinds of amazing things, particularly because technology is accelerating. In that regard, finally, space technology technology caught up to space. It is impacting space directly. And one of the major achievements has been the smartphone. We can take smartphone electronics and directly fly them in low Earth orbit without next to no modifications. They can, in fact, withstand the radiation conditions, the temperature conditions, just because they've become so hardy. And that's just sort of the initial, break in this invisible glass ceiling that is space exploration. Partly because of how much energy it takes to escape Earth's gravity well. Then, of course, there's an ongoing revolution now with building better and low-cost rockets. And making rocket rides prominent, but also routine enough that it's not a dangerous task anymore. We're not quite there yet, but we're getting there. And so in the midst of this, we have been looking at whole new ways of exploiting these advances towards enabling humanity to explore further and deeper into the far corners of the solar system. So we could say, there are places on every planet that we have explored so far that we've gotten great pictures, but there's still places that that have remained untouched or unexplored by humans or by human-led robotic crafts. And let's just speak, for example, about the Moon or Mars. There are extreme environments on the Moon or Mars: craters, canyons, cliffs. That you would see just like on Earth, but that are unreachable by current robotic spacecraft. And so that's a starting point for us: how to send next generation crafts to go out and explore these environments. That's where all the interesting interest lies, particularly for the planetary scientists, particularly for the geologists. Same with Mars. Then we're looking at different kinds of platforms. Not just rovers and wheeled vehicles. In low gravity environments, rolling is not the most efficient mode of transport anymore. It's actually jumping around. And so we're developing robots that will go out and sort of jump around to explore from place to place. And then, of course, just recently we saw the Mars helicopter and how much excitement that brought, all the potential of having an air vehicle. And so we're also exploring similar things about sending air vehicles to a lot of these planets, because a lot of them are gaseous. A lot of them have a great atmosphere or thick atmosphere. And so atmospheric exploration is a very credible future entry point to learning a lot more about our planets.
Can we break it down into the specific technologies and engineering and entities that you have created as a team, from the SpaceTREx robot right the way through to CubeSats? Can you take us through the very specific engineering innovations and technologies, sure, so that we have a context for the big idea that you're going to be taking these breakthroughs and innovations to?
Yes. We've taken a lot of the work that we've been developing over those past 8 years and have amalgamated them, or they've become aggregated in a sense to something bigger. And the SpaceTREx project is one of them. It started off from the very beginning. It's a spherical robot that's meant to be like a quadcopter operating in off-world environments, particularly when there's no atmosphere. So instead of propellers for flight, this thing has rocket thrusters or a hopping mechanism to move around. And it of course has navigation and onboard cameras and the ability to take on the latest and greatest science instruments, provided it can fit in a miniature package. The whole thing is the size of a beach ball, so about 30 centimeters in diameter. That's been one of our longest efforts, but that's sort of a representative of our other projects. Other areas where we've been making significant headway has been in the infusion of machine learning and artificial intelligence in the design of next generation space missions. And so we've come up with a tool called IDEAS, which is the integrated design engineering of swarms, autonomous swarms, and being able to use swarms of spacecraft to go out and explore not the 8 planets that we've now all sort of explored and got great images, but some of the 2 million asteroids which are yet to be explored. 2 million plus asteroids, that's still sort of the tip of the iceberg. We may see many more that are even smaller, that could be the size of a suitcase. And so that's the sort of this next generation of exploration that we're going to have to do to learn about how the solar system formed, going to these bodies. So IDEAS is a tool that we would develop that enables teams of spacecraft to go out rapidly and perform reconnaissance of a moon or an asteroid. Then we have ADAMCO, which is another tool, which lets you do automated robot design for planetary exploration, but do so rapidly. So oftentimes, you have a new mission coming up, and oftentimes, the deadline for applying for this proposal might be a matter of 30 days to 90 days. And you can, of course, try to adapt for every new situation, but it of course becomes very challenging with a small university team. We're talking about a team of 20 to 30 individuals. Oftentimes, we're also competing against NASA centers and space agencies where you may have thousands of people who are all as qualified as you are. And so we're using machine learning to even our odds in that sense, so that we can have teams of 30 people compete against teams of perhaps 100. The advantage, of course, is machine learning is improving constantly. Every 18 months, we're still following Moore's law. We're seeing doubling in computational speeds and power. And of course, the other is just being able to use machine learning, in our case, to come up with out-of-the-box solutions, creative solutions that otherwise humans may not have thought of. We may have our own biases. We may instill ourselves into sort of thought boxes, so to speak. And the machine learning systems can sometimes break that because they're sort of starting off from blank slate, and they're exploring almost like infants, whole new things. So that's a whole area that we've been doing through several of these mission design tools. Then we're developing femtosats, which is a platform that's even smaller than CubeSats. Their dimensions are 3 centimeters by 3 centimeters by 3 centimeters. That's the 1F femtosat. We made a major announcement of that in 2016. The big advantage is that it can reduce down cost. So you can send one of these things into space right now, if possible, for about $1,000 to the low Earth, or particularly the International Space Station. If you were to send it out into low Earth orbit into a sort of a free-fire orbiting mission, it would be about $3,000. And that's a significant reduction in launch cost. But of course, the spacecraft is a lot smaller. But the technology is there now. We have miniaturized everything to the point that, Sputnik can now fit in, the palm of your hand, sort of, including with advanced instruments such as cameras, laser rangefinders, and so on. So that's been another, and we've been looking at use of femtosats now, deployment of swarms. And that's a whole new way of exploring with things like femtosats. At the moment, when you have a spacecraft, it's usually one large spacecraft. It goes out and takes a picture of an event, takes a picture of a planet, and so on. With femtosats and these distributed small spacecraft, you can send tens, hundreds, maybe even thousands of them to do multi-point observation. So think about measuring a cloud. Observing a cloud from a distance, you're taking a single photograph. That's great. But there's so much complexity in that cloud in terms of all kinds of variances and distribution of perhaps different chemicals, temperature differences, differences in humidity, for example. The next possibility is actually to get multiple samples off the cloud and be able to bring that together. And so that gives you a lot richer data. In fact, that's the type of data atmospheric scientists are looking for to better describe our climate and our weather systems. That's the next level that we need to get to be able to better describe complex systems like Earth's weather. And similarly, the same could be said for off-world environments. And so those are really the big projects. I should add, the one new emerging area has been developing and branching off out of femtosats is the idea of coming out with miniature balloon payloads that would be flying in these off-world environments where there's an atmosphere. It could be Mars, it could be Venus, it could be Jupiter, of course, and the other gaseous planets. The idea here is to send payloads that are less than 100 grams, that would have all the latest sophisticated instruments, and we can send tens, hundreds of them, and they would be forming a constellation around these planets to constantly observe events up front and local and in situ. And imagine being able to be in the clouds of Venus or Jupiter and getting that upfront images. It's going to be sort of mind-blowing just thinking about how otherworldly it is. But those are the possibilities that's going to be coming out with technologies like this. Individually, when one of these things encounter some kind of dangerous situation, when they get damaged or destroyed, it's not game over. We have many more to sort of replace them and keep the mission going. And so for that matter, it's going to be a whole different way of looking at missions. It's a whole different paradigm that ultimately enables us to do more.
You are also looking at the technologies and engineering within the area of extreme refrigeration using quantum mechanics. That's
a very new area we've looked into thanks to efforts on the Lunar Ark project. And it turns out exploring the moon is where this technology might become important and very critical. Naturally speaking, cryo conditions or being able to operate at cryo conditions have multiple applications and multiple environments. On the moon, the permanently shadowed regions, which are of great strategic interest for us. That's because most of the water reserves on the moon are likely to be in these places. They have been in the dark for millions of years. The temperatures are well below -150. And current robotic systems, current mechanical systems cannot operate under those cold temperatures. Just because all sorts of strange things happen, everything from jamming to fusing of metals. And so that poses major challenges for conventional ways of doing things. And that's where quantum methods come in, which is a whole new fantastic area. We have barely scratched the surface in this, but the idea of being able to lock objects between themselves, but having them at a distance, having no direct physical presence between them. It's almost like you have an invisible barrier, maybe invisible strings and rods attaching them and holding them together. But you could literally walk through these things. And so in many ways it's out of this world. It almost sounds magical, but such phenomenon appears when you get to such cold temperatures, particularly using superconductive materials. And so in that sense, we're also getting started. The other, of course, was cryo storage, as you mentioned, of substances. And cryo storage may be very interesting because that may be a way to store biomatter, including eggs, sperms, seeds, and spores for long periods of time without any kind of oxygen degradation. And so if you can store them in cryo conditions, they could last maybe hundreds of years, maybe thousands of years. And that of course alone has many benefits, apart from just saving our DNA as a backup to interstellar travel. At the moment, all modes of interstellar travel are going to take tens of years, hundreds of years, so on. It's going to be a long waiting time, and if we're going to have people alive, they're going to go through many generations. Perhaps, and going back to sci-fi, storing them, freezing them in this form may be practical.
Let's talk about the way the project, the Lunar Ark, came about. Can you take us through the process from ideation right the way through to getting it to this stage of the project and the problem it solves? If we can go through the specifics of the problem it solves.
Right. Thank you for that. SpaceTREx has been active, as I'd said, for 8 years, and in that 8 years, we had some notable events that happened that I think both sort of ignited and better related to us, some of the dangers that we face. In 2013, just as the lab was being formed, we had a major event happen, and that was Chelyabinsk. There was a meteor impact that happened over Russia that caused a 500 kiloton explosion. That explosion is maybe 50 times that of Hiroshima and Nagasaki. Had it impacted a city on the ground, it would have taken out maybe 100,000 people. Luckily, did not. It exploded midair, and instead, a lot of people still got hurt. A lot of glass damage, and due to shock and vibration. Nevertheless, that was a close call. That's likely to happen every 100 years. Before that, we had Tunguska, that was also in Russia. And back then, people were totally perplexed seeing this huge explosion in the middle of Siberia with all these trees flattened, major firestorm and secondary activity. And of course, you can then go back and see, these events. There are events that happen at a 100-year scale. There are then events that happen perhaps at a 100 million year scale. And the 100 million year scale is quite scary. By all accounts, because that goes back to the KT event that wiped out the dinosaurs, in which we had either a comet or an asteroid, that's the latest word, about 4 to 8 kilometers that impacted Earth. It would have ruptured the crust, caused a series of secondary events, including a never before type seen tsunami, firestorm, and both of which would have produced all kinds of damage all around, physical damage. But the firestorm would have been the worst because it would have created a lot of ash in the atmosphere, which would have then blanketed the planet. Blanketed it enough such that the temperatures drop, perhaps for 100 years or so. Similarly, another close call for humans was the Toba supervolcanic event that happened approximately 75,000 years ago. And there, it was likely that there was a massive ash cloud. The evidence indicates at least 10 years of continuous winter, followed by a 1,000-year cooling cycle. Back then, humanity, Homo sapiens sapien, was around for about 75,000 years. And it is likely that Homo sapiens sapiens who had gotten out of Africa would have been wiped out because of the extreme conditions. And that's interesting because indirectly, we've also been, there's been advances in DNA technology to look back to, sort of our, great ancestors. And it does not go back beyond 75,000 years, even though the indirect evidence suggests humans have been around for at least 200,000. So what about that first 125,000? It's missing. And that could be due to these bottlenecks that have been caused by something very close, like a Toba near extinction event, in which it's thought that the population of humans would have come down to maybe about 100 to 1,000 people. And so humanity has had many close calls. Between generations, we've had very close calls. And as a space systems design group, we've been better learning about all of these things. And one of the things we've been looking at is how to utilize space technology, perhaps not to solve all of these problems, but some of them. Provide early warning, provide some kind of measure for humans to take some kind of proactive action for safety, of course. The two areas where space technology could really help is with predicting solar storms. Solar storms are probably, from my point of view, the most dangerous, most immediately dangerous for human civilization at the moment. In the 1850s, we had the Carrington event, in which a massive solar eruption happened during solar max on the sun. That event caused all electrical systems here on Earth to literally get fried. You would see, the nighttime sky turn into flashes, literally, for a period of months afterwards. This was all of the electrical activity that was happening in the atmosphere. Our magnetic field literally got sort of blown because of the solar particles coming up. If that were to happen now, our electrical equipment, which is everything that we really depend on, satellites, all kinds of other surface electronics, could get fried. And there was a study done in 2008 from the US NRC, National Research Council. It predicted that the United States alone would be without electricity for 10 years. And so that's a very bleak picture. It was so bleak, people closed the book and ignored it. And so that's where space technology could help to give some advance warnings of such an event occurring, and for us to somehow take some level of proactive action, whether to, if there are electrical instruments, have some kind of shielding to be put on, or move away satellites so that the shielded side is encountering such situations. The next, of course, is meteor impacts. The KT event is massive, and we have made progress. I think we can now better detect KT type events, but we can still, but Chelyabinsk type events, maybe not. We had no warning of Chelyabinsk, and we probably still don't. And for that reason, having a constellation of satellites monitor this would have been giving us, great capability. So we were in this mode of thinking, looking to duck and avoid and do all kinds of early warnings with space technology, when we soon realized maybe that's not the only situation we're going to have to deal with. Maybe, sometimes it's like a soccer player, or I should say a goalie in a soccer match. Sometimes they can, keep away that ball, but once in a while that ball is going to get through. And so in this case, what do you do in a situation where that cataclysm does happen? And so that's our sort of thought process. Our thought process shifted towards, what if a cataclysm does happen? How do we, perhaps recover from that? How do we perhaps, deal with this?
If I can interject, please. One of the, in a sense, less dramatic sounding issues is the loss of biodiversity. And if the Lunar Ark is set up, it's going to store anything from seeds to spores to sperm. Technology is advancing rapidly in this area, and if things are safely stored there, there's the possibility in the future of protecting against further loss of biodiversity, which is extremely attractive. Can you talk to us a little bit more about that?
Yes. So in parallel to all of these, potential cataclysms, we are also seeing the steady loss in biodiversity. Some of it is in humanity's control, some of it's not. It's happening without our knowledge. It's almost happening without our control, and it's very concerning. Certain creatures more than others directly impact our food supply, particularly creatures like the honeybees. But nevertheless, there's a whole rich biodiversity out there that we've barely explored or know about, that are getting wiped out in large numbers, in large scale. They're getting extinct overnight, so to speak. And this kind of method of being able to store them in cryo conditions could be a method of preservation. If we had that in the days of when humanity was first exploring the islands in the Indian Ocean, we could have saved the dodo, for example. We could have saved all kinds of other creatures that could have in these last several hundred years become extinct. And so the technology is there to at least save them, not necessarily bring them back to life, but at least save them for another day till the technology further advances. And we're of course making very rapid progress here to then bring them back to life in their original form. The other factors could be diseases. There are time to time diseases that could come out and wipe out an entire species. And so in that sense, having a stored copy of them could help us bounce back from that disease. Maybe the disease, takes its way, wipes out an entire population, but then we can reintroduce it post-disease and sort of deal with that. So all of this gives us the ability to, protect our rich diversity, our natural habitat in all sorts of interesting ways.
There is a global seed bank in Svalbard, an island just off Norway. What you're proposing will be much broader than that. Can you talk to us about how you envisage this happening? For example, the storage area will be in lava tubes on the moon. Can you talk to the audience about what those are, temperatures in the lava tubes, and also how you plan to get all the equipment and samples, of course, to the moon?
In the 2013 timeframe, there was a great discovery made of nearly 200 lava tubes on the surface of the moon. And it's likely these lava tubes form networks. These lava tubes are only about 4 to 5 days away from Earth, and they're likely pristine for 3 to 4 billion years, because the moon has not undergone any kind of active tectonics or volcanic eruptions for so long. And so, imagine within a 4 to 5 day travel radius, what else is there that is untouched for 4 billion years? On Earth, there's nothing like that, because everything gets recycled through plate tectonics of some kind, through weathering, through erosion. And so for that reason, that became very interesting for us, that something like this could be untouched for so long. So given that, that could be one of the best places to protect what we most value here, in this case, the Earth's rich biodiversity. And we could store them in this, cryo form, as opposed to, sort of having something like a mega zoo, because operating one and constantly providing the resources for that is a lot more prohibitive. In this case, you would keep everything in stasis in the form of eggs, sperms, spores, and seeds. And so they would be stored in these lava tubes. The lava tubes, as I said, have been perhaps untouched for 4 billion years. The temperatures in these lava tubes are, incidentally, a constant minus 25 degrees centigrade, which is the remnants of the heat of formation of the moon. On the surface of the moon, it's a totally different story. In fact, the things are very inhospitable. Temperatures can go, 120 to 150 degrees centigrade in the daytime, and drop down to about minus 150 in the nighttime. Days and nights on the moon are, 12 days of day, 12 days of nighttime continuous. Then, of course, you have solar particles constantly being bombarded from the sun, and of course, interstellar particles. These are all forms of radiation. And then top it off, you also have micrometeorites. These are almost like little machine gun bullets coming at very high speeds, and they can have very serious impact, particularly on astronauts, on any kind of equipment. They get rained on, constantly. And so these lava tubes are about 80 to 100 meters below. They're carved into solid granite, and for that matter, they're sort of well preserved. And so storing these seeds in this cryoform would be ideal. This is going to be slightly different from what Svalbard is doing, which is they're storing their seeds around minus 18 to 20 degrees centigrade, and that's a form of seed storage for long duration. We're looking at a separate technology, which is cryo storage, which lets you go for many decades, if not hundreds of years. And so this is a more of a longer term permanent solution, a little more expensive, of course, having to refrigerate at such cold temperatures. So even though the background temperature is going to be a constant minus 25, we need to get this down to minus 180 or minus 196. And so that's one of the biggest engineering problems, how to bring it down that cold. And so that's where we spent a lot of our feasibility studies in coming up with this concept. In fact, that is one of the make or break moments. Can you refrigerate these seeds and biomatter for that long in those lava tubes? And for that matter, we have identified that we could at least do it with solar power. Solar power would be located on the vertical on the surface of the moon, and it would generate the power over 12 days of daylight, and then you would store the power for the remaining days of nighttime. And otherwise, several of the other engineering challenges are not out of the ordinary, are not too difficult. In fact, they're reasonable under conventional situations.
Can you talk to us about how the plan is to use the other technologies beyond cryo refrigeration? For example, you will use the small robots to explore the lava tubes. Can you take us through how the technologies and engineering that you spoke of at the beginning of this conversation will be used within the Lunar Ark big idea?
Sure. So to date, even though we've discovered these lava tubes from orbital imagery, and there are about 200 of them, no human astronaut has set foot on them, no robots have set foot on them because of their extreme conditions. And so what we've proposed is the SpaceTREx robots are perhaps one of the well-placed robotic platforms to go out into this environment, because they could literally fly and hop their way into these lava tubes. The entrance to this lava tube is almost a vertical, tube that's about 80 to 100 meters deep, and then you fall down into this pit, which then has a bunch of interlinking, tubes that look almost like subways, but a lot bigger, 80 to 100 meters in diameter, and stretching perhaps for kilometers. And so to get into that is not trivial, of course. And so having a flying hopping vehicle could do that. We need to do a mission of some kind like that to first get an idea, to first prove our hypothesis that indeed, these lava tubes have been undisturbed for 3 to 4 billion years, that their current state is pristine, that they're safe, that they're not going to collapse anytime. And the other factors we may also want to check on is the radiation, natural radiation from the granite rock, and if there's any remnant radiation there. The other factors we may also look at is, are there additional resources we could exploit? An interesting surprise could be that there could be water ice in these lava tubes as well. And if that's so, that could be a major game changer, because then you don't have to go to the permanently shadowed crater regions to get that water. Rather, it's going to be right there for you. So all these factors need to be sort of accounted for. It needs to be a systematic, step-by-step exploration. And for this Lunar Ark effort to take hold, we would need to do perhaps 1 or 2 of these exploratory missions first, to get to one of these target lava tubes, send a lander that would then deploy these SpaceTREx robots, or it could be a rover, get into these lava tubes, map them, get all kinds of important data that the geologists need to better confirm these hypotheses, that these are what we're talking about. And once we have those detailed images, laser range finding data, in other words, a 3-dimensional map of these lava tubes, then we can take it to that next step of planning and building a base inside. And of course, considering how precious and old they are, untouched for 3 to 4 billion years, they stand as monuments. We would also work towards, if you're going to build a base in there, to maintain as much of that natural material as possible, and not necessarily destroy it for the purposes of a human base.
So you have some upcoming news.
In the next week or so, at the Interplanetary Small Satellite Conference, we're going to be giving an update to the world about progress that we've been making on the Lunar Ark project. And I can give you an early sort of indication of what those are, and that is on 2 fronts. We've sort of branched out into 2 fronts, further exploring and advancing the Lunar Ark concept. One is we've been looking at how we could start the Lunar Ark project in the near term. In the original idea, carrying the 6.7 million species is great. It's going to take a lot of resources. It's going to require advancement in cryogenics. We think it's at least 30 years away. But can we get started now? Can we at least start to save important biomatter as we speak? And so that's the second thrust that we're looking at. What would it take specifically to go out and explore these lava tubes in one mission? And in that second mission, what would it take to take seed samples, just like from Svalbard, and deploy them into these lava tubes? And so we've been doing some early feasibility studies on those fronts. And on a second thrust, we've been trying to, we've been identifying the component technologies that are needed for this whole effort of the Lunar Ark. And one of that means transport of all this biomatter from Earth on at least a 5-day journey to the moon under cryo conditions. And so you need some kind of cryo container that could do that for you. And so we've developed a prototype cryo container experiment. And so we will be sharing details about that in this upcoming conference. And that too is another effort to further build up the building blocks necessary for the bigger project.
Thank you very much for sharing that. It's an honor to get news before everybody else. Could you maybe, if you don't mind, give us some details on the A team that you would like on this project? If you were given the choice of people from different fields to make this happen, from scientists right the way through to explorers, innovators in different areas, businessmen, philanthropists. Who would you like to be part of this project to make it happen?
I will try my best to perhaps paint as representative picture of this effort. In true form, this is going to be a massive effort. And so accounting for all the people that you need, or even a significant number, you can easily miss it. So given that, I think one of the things that we think is a way to go with this type of effort is that it will require some kind of foundational support. And that's how Svalbard occurred. Not through governments, not through intergovernmental agencies like the UN, but it started off with a person, a team, a vision that sort of then rolled from there, and then it got foundational support. Foundational support then led to support from a country like Norway, which also saw that vision, and so that's how we also sort of see this going down a similar path. Given what I've seen, I think somebody like Jeff Bezos is very well placed in terms of the resources that he has. And the vision that he has for humanity's future to be interested in something like this possibly. Elon Musk definitely is another individual. Many of the individuals who are looking towards putting a path for humanity to go and live off-world. And that, of course, is a very compatible vision with this. Because if we're going to do this, if we're going to go off-world, we couldn't go alone. And maybe even with our pet dogs and cats, it's just not sufficient. We need to carry a whole ecosystem with us. That's the reality, and that the ecosystem is what's going to sustain our health, our well-being, our quality of life, and so we need to sort of figure that out. And so having this Lunar Ark actually helps safeguard that, helps propagate that effort of us being able to then take these copies to build great nature reserves on orbit, just like the concept of O'Neill cylinders. Then, of course, I would say in terms of support, currently we have seed funding from NASA to show potential new utilization of lava tubes, but ultimately, a entity such as NASA, such as Space Force, will have the capacity and capability to see this through and operate this through. So we would also need lots of support organizations in that respect. Apart from that, I would say the other is individuals just like you out there. All of you are going to make a difference because it's sort of eye-opening, part of what we've talked about, part of the story behind this. But the other is, we all collectively matter. We are all part of that collective decision process because it is, after all, our Earth here that we're trying to protect. And so, your voice, your vision is going to be transformative in that respect. And it's more of, not necessarily, predicting doomsday tomorrow, but it's as people, come to a certain age, they figure out that, I got to write up a will for myself. That's not presuming bad things are going to happen here. It's just the way, you want to preposition yourself, be well organized. And as a human civilization, we want to get to that next level of maturity, to not necessarily be reactive to disasters as many times we are, but now become proactive and be ahead of the game.
Obviously, you, in as far as what the future holds, you would like this project to come off. Who wouldn't? But how do you have your big conference coming up? How do you think the chronology will work? What are the steps for the next 5 years, for example?
Fantastic question. I would say it would have to be a very systematic process. Part of that process would be exploring of these lava tubes, validating and verifying their pristineness and usability for such a base. Another, of course, is advances in rocket travel itself. Currently, rocket travel is prohibitively expensive. We have suggested to, carry all the biomatter for the Lunar Ark would take around 250 rocket launches. There's never been a human-led mission of that size. The nearest that has come is the space station, International Space Station, that took about 40 launches. But that's where the promise comes in. With all these new advances in new space, thanks to folks like SpaceX, thanks to this private-led race, the potential is there that rocket prices are going to crash. If the prices crash to say $100 per kilogram, maybe even $1,000 per kilogram, that's going to be a complete game changer now. Now launching 250 rocket launches is not so prohibitive anymore, and we have a lot more capacity to be open about those things. Then of course is the resources that we need to carry to set up the base, and there too, apart from the cryo aspects of things, everything else is quite conventional. Everything else is stuff that we can sort of see being developed with present day technology. So it's only going to advance in the next 30 years. So cryo technology is the last, I think, hurdle that needs to be advanced, and that too can be advanced, thanks to investments here, steady investments. All other aspects of robotics has been accelerating, has been showing all kinds of great advancements. We can see cryo robotics taking on that role as well. We couldn't sort of see any sort of major roadblocks there. So all these pieces need to come together, be matured, and then when finally a paper proposal that is ready to fund is there, the technology is ready and mature and ready to roll out. It's not a research project anymore. It's a developmental project, just like the International Space Station. And then the other, of course, is the need for unity amongst all the tribes of man, for such a great effort to happen. This international cooperation. We showed that success before with the International Space Station. The different components of the space station were built in different countries. They never came together on the ground. The first time they came to ground, first time that they were interlinked was in space, and they worked perfectly. So it shows if humans can come together, cooperate, we can do great things. And something like that is needed for this effort.
It is an interesting thought that this could be the project that binds us all together, brings us together, and encourages us to collaborate in unprecedented ways. At this point in the show, we ask our interviewees about rich connectedness, the people with whom the interviewees you have connected with during the course of your life to move your human story and your work forward. In your particular case, it is even more interesting because whoever impacted you richly, connected with you richly, may, through your work, end up impacting all of us and our future generations. So I'd really like to ask you that question. With whom have you connected richly in your life to move your work and human story forward?
In this last era, since starting up SpaceTREx, I would say, one of the main dominant personalities who's been a great influence and who's been a great collaborator with me has been Professor Jekan Thanga, who's a planetary scientist. He's a leader in the area of asteroid science and technology and exploration. Collaborating with him, the idea of an engineering research group working with scientists side by side was something that we very much valued, and a lot of great ideas came. And so he's been part of our group ever since. Part of being sort of the brains behind a lot of all these interesting ideas we've been putting together. Then, of course, I would say, the other personality who had a great influence on us, who actually gave us the spark to want to look at lava tubes and these extreme environments on them for the very first time was Dr. Mark Robinson. Him and his team were the ones who actually discovered the 200 or so lava tubes in 2013. And so he was out there to convince me at that time, a much younger roboticist, to think about exploring this new environment and finding ways to sort of utilize it. Our early thoughts on this was for use of these lava tubes as human sanctuaries of some kind. Then I would say, the other influences in my life, both in terms of sort of technical advances, have been my previous postdoctoral advisor, Dr. Stephen Dubowski out of MIT, and my PhD or doctoral advisor, Dr. Gabriel Delatario. And in many cases, the technical capabilities that I've been able to show and sort of advance have been, thanks to their mentorship. And so, it's been that steady buildup of capabilities that has sort of brought us collectively to this point now. So I would owe a lot of thanks to them for certainly influencing me and giving me the resources to take on these kinds of problems even in the first place. Particularly to Professor Dubowski, because he was the initial vision behind sending robots to go out and explore sort of the next chapter in exploration, particularly extreme environments, and being able to do so in unconventional ways, not just this one big rover or spacecraft, but rather smaller disposable systems. And he then sort of committed to further advancing that technology over his lifetime. At a later stage, I got in. I was involved in looking at power and the challenges of power, and then we further advanced along the path. And so I would say those have been my big influences, all sort of influencing me both on the technology and I would say the underlying philosophy behind going after this, but also that greater vision of utilizing engineering for the greater good of humanity. And so going into space exploration, we're not going to be escapists. We're not trying to run away from Earth's problems, but we were ultimately also looking to better see ourselves in the mirror, learn more about ourselves, and ultimately protect Earth and see a better future for our humanity and the rich ecosystem that's around us.
Jekan Thanga, head of SpaceTREx, thank you very much for your time, and thank you for moving the human story forward.
Thank you. Thank you for having me, and it's been a pleasure to talk to you.
Thank you very much for being with us on this episode of the ideaXme show. Our mission is to move the human story forward by sharing knowledge of the future. You can find us across the internet on all the major audio podcasting networks at www.radioideaXme.com, YouTube and Vimeo. Please subscribe